This is whipped together in a rush. Just yesterday I was informed that there are some lightning talk slots left, and it's totally okay if it doesn't directly have to do anything with GNU Radio, as long as it's interesting. And maybe I can, most of all, amuse you with some circuits. So I tell you a tiny story. So I work at the experiment electronics department. We do not so much work with continuous waves and phases and stuff, more like amplifying pulses from detectors to bring them to a level and maybe shape them a bit, to digitize them in the end and finally write them to disk at some point. Yeah. Okay, so sometimes while student interns spontaneously appear in our department, something like my boss says, like, oh, there's some student interns coming and there's a very smart one and I actually wanted to deal with him myself, but now I have to go to this conference, like here's a student intern for 2 weeks. Don't do that. Yeah, so meanwhile, there's a hook loose. Oh yeah. We have some go-to projects in our department, and depending on the skill level and or motivation, we build something like a traffic light state machine with an Arduino, or a self-exciting magnetic pendulum, or we also build sometimes a photodiode, like from a cheap photodiode with some amplifying stages. You can, if you shield it from light, you can actually detect beta radiation. And yeah, that's what I built with this 11th grader. And yeah, it was actually Mr. Smarty Pants, and he was quite bright and was very hardworking and was finished with his radiation detector already at the end of the first week. And it's not just building the radiation detector, he also learned KeyCut, and we actually built the electronics on a small laser cut PCB. And so he was eager to do more, and he found the other projects boring. So yeah, let's whip something together to keep him occupied and possibly build another board, yeah, with what he knows about KeyCut. And yeah, so I made the following offer, like we could transmit sound over a laser pointer. And he Googled a bit, and then after 3 minutes he found a YouTube video. Boring. Yeah, okay. You just have your audio source, you somehow feed the signal into a laser pointer, then pick it up with a solar cell connected to a PC speaker. What's the big deal? Like, where's the electronics? Where's the fun in that? Boring. Okay, so I made the following offer. Yeah, but how about we do it in stereo? And yeah, first week was over. I went home. I grabbed a breadboard and components that I had laying around, turned on my oscilloscope, and tried to whip something together, hoping that I would finish in time to give him instructions to build this. And yeah, first, I think I do the demo now first, so it's more impressive if you don't know yet how it works. So, I have some receiver here. At the moment, it's receiving bullshit. So we have a tiny laser card board here. We have some DIP ICs on it, some op amps, and some logic chips. And the photodiode sensor is here. So this CD-ROM is actually like a practice target disk, so I can aim better, but it's like 5 by 5 millimeters. And I got a sender here, and I still need a signal source, which I forgot here. But it's all prepared in principle. Oop. So, playing back some audio, turning on the laser. Don't worry, I won't aim at you. Okay. And now I'm hitting the target disk. Okay. Turn up the volume at the sender. And it's Led Zeppelin, because let's zap that receiver, yeah? Haha. So, huh? Frank Zappa, okay, it's also good, yeah. And, yeah, now walk. And that's the best part, yeah? You can actually use this as an instrument. It actually sounds like a laser gun by coincidence. Okay, so, and I said it's stereo, yeah? So I have prepared another audio file. Okay, so it could be a mono file, like just saying left and right, but how about I disconnect one of the speakers? I don't know which it is. There's a tiny bit of bleeding between the channels, but okay, now the thing stopped. But yeah, I guess you heard it. We have stereo. Thanks, thanks. So now I can actually explain what is happening there. So I quickly photographed my concept drawings. I could have showed you the keycut schematics, but they are too convoluted with all the decoupling things and wiring the packages right. But a general concept is, first of all, any guesses how it's done? So also I can tell you, once the laser beam is in the vicinity of the sensor, it works and it doesn't change the volume with the intensity at the sensor. Just if you surpass a minimum amount of signal, it just works and keeps the volume stable. Close to it, but actually I didn't know which channel I was going to unplug because I didn't remember yesterday when I tested it. It actually keeps the channels like the assignment of the channel stays constant, even if I yeah, cut the beam. Any other guesses? Okay, I already showed like a bit of the schematic. So it's actually pretty straightforward. I do a phase modulation. So first of all, like I generate a square wave and also a triangle wave, and they are synchronous. They come from the same oscillator. One is just the integral of the other. Yeah, that's a common op-amp basic circuit. And here is my audio. It just gets buffered and a bit amplified. And then I have a discriminator, a comparator, yeah. And yeah, the triangle goes up and down and up and down. And I have an analog multiplexer that for the rising edge of the triangle selects the left channel, and for the falling edge of the triangle selects the right channel. Yeah? And so you have the left edge of the resulting square wave wiggle with the left audio, and the right edge wiggle with the right audio. Yeah? Then you have a tiny switching transistor, and you give this to the laser diode, and that's the entire sender. Yeah? So how do you receive this? First, there's the receiver. It's also very, very simple. You have this tiny cheap photodiode, and I just used 3 gates of a hex inverter, an old CMOS hex inverter, wired as a very high gain amplifier. Yeah? And it's AC coupled, and with this feedback, it's self-biasing. So no matter how big the received signal is, it's always through the AC coupling located around the switching threshold. And once you surpass a minimum amount of visual signal, like you get a logic signal out again. And This feeds into the demodulator, and it's basically, two old school CMOS chips. It's the classic PLL DIP chip, and two D flip-flops that are wired as toggle flip-flops. Yeah, how does it work? We have basically this PLL to lock onto the average of the leading edge. Yeah? And we have a very big loop filter. So basically the audio gets filtered away, and we get a waveform that is on average in sync with the received signal. Yeah? And yeah, then there's some gymnastics with doubling the frequency of the VCO and dividing it down again. So I don't want to get into detail, but it's pretty straightforward. So I can get a signal that is 90 degrees out of phase with my received signal. And this is basically something I can use as a mask together with an AND gate to, I mask this recovered, stabilized clock signal with the received signal, so I can cut out the wobbling of the right edge only, low pass filter it, and then I have my DC or audio. Yeah, and I can also do this with the inverse of this recovered signal, and then I cut out the left wobbles. Yeah? And yeah, then you can do some filtering, either second order cell and key, or it would probably just work with an RC thing, and then you get your audio. And that's it. So one weekend of tinkering produced a project that the student could build, could make PCBs, and it kept him occupied for another week until the end of his internship. And it really worked. He got it finished on Friday afternoon at 3 o'clock, and it just worked, and then everything was over, and he was happy, and he was allowed to take it home. And yeah. I showed you now a replica that I built myself. Yeah. Okay, that's it. Thank you. I hope that